Is that a yes?
Yes.
Yes,
Yeah,
yes.
great. Um, so what, you know, Hanif mentioned it might be nice to have an agenda, each time before the meeting. So I attempted to create an agenda. But I know that today, Keysight wanted to give a talk about items that are top of their mind. And we also had a really nice discussion with Keysight yesterday internally. And then was hoping we could talk about the Sci Library generation if we're ready. So that's what I have. Does anyone else have something we want to put on the agenda? No? Okay. We can go ahead and get started. Chris, do you want to go ahead and start with the Keysight end of things? I thought he was here. Hey, Diana, have you seen Chris?
Yes, he joined and I think he's restarting his computer or something.
Oh,
Let's
okay.
give him
Okay.
a couple more minutes.
Okay, great. It's 9:04. Marian, did you want to? Oh, go ahead.
He says he's having some PC issues.
Okay. Marian, did you want to talk about the this commit from yesterday? Or anything else?
One that was sitting there for a few weeks. I managed to fix the conflict, and now it's in. It was actually Chris was asking for that one because his plans for CI/CD pipeline in Dash repo were pending this commit. So yeah, so I finally fixed all the conflicts and now it is in.
Awesome. Anything else you wanted to share while we're waiting for Chris?
No, I guess not. There isn't anything new from the last demo when I showed all of the stuff.
Okay. All right.
I think Chris needs a couple of more minutes.
Okay, that's fine. And just for everyone else's edification, if you're not in the high availability or behavioral model meetings, we've been working through those, trying to continue to make progress with requirements, especially for HA. And we've been also working through the behavioral model items in the project. So that's been great. And I appreciate the contributions from everyone. And I know we should probably generate a list of, the SDN team right now is very focused on delivering their proof of concept out into our data centers, but in a couple of weeks, they might have some time to come back and visit with us about, our questions. I know they have quite a few things on the list. They know they need to deliver the metering, the counters, the telemetry, the billing, those kind of things. So those are on the list. And so as soon as they can lift resources off what they're doing, they can shift over and answer our questions. And of course, I know we have more as well. Hey, Chris, have you joined?
Yes, I have. I had to reboot
Hey.
twice.
Oh, that's okay. That's okay. We
everyone.
just, sorry about that, Chris. We talked briefly about the conflict fixed by Marian for this commit right here. And I'm going to go ahead and stop presenting. I thought Keysight had possibly wanted to talk about a few items on their end.
Yeah, great. I'm ready to go. Everyone
Okay.
else is. Thank
Okay,
you.
I'm gonna stop presenting in case you need to present.
I'm going to
Or
present.
do you? Are you gonna present? Okay, stop.
So, hey, everyone. Nice to be here again. I wanted to give a little update on where we are with respect to CI/CD testing. I've been talking about that off and on for a while, and I wanted to just kind of give an update and get feedback from the community, and also talk about what some of the dependencies are and where we maybe could use some help. So This is what I plan to go over. And I just wanted to refresh people from some diagrams I presented a few times in the past. This just
Yep.
shows a diagram of testing two different P4 models. One is the BMV2, and the other is a future P4 DPDK version that Intel is developing.
Mhm.
And this shows software traffic generators testing the P4 model. And we wanted to run it as GitHub Actions in a CI/CD pipeline. And the idea is when you do a commit of some kind of change, you build all this in the Azure cloud. And it's part of GitHub, and it will build all these artifacts and run tests automatically every time you do like a pull request or commit. Does anyone have any questions about that overarching concept?
So the section on the bottom is the BMV2. Got it.
Yes, this is
Yeah,
what's
okay.
currently being built, and this is
Okay.
futuristic.
Mm-hmm.
And so right now,
Chris, I have a quick question on the traffic testing.
yes,
So, you mentioned that with DPDK, you can have software traffic testing. I think we can also have it some sort of testing with BMV2 as well, will we not?
well, both of these actually can run in pure software in the cloud or in your development environment, pure software. So they're really, the difference is P4D PDK will be, one of the differences, it'll be much more performant. I mean, there's probably a lot of other differences we could get into in the future. But the real distinction for the purpose of today's discussion is just the performance of these two approaches primarily. Does that make sense?
Because one
Yeah,
is
yeah,
line rate and one is not, or something
Well,
like
yeah,
that.
DPDK, this implementation is very performant, right? It's probably can do 1,000,000 packets per second or faster. This BMV2 is really more of a an engine-driven kind of metadata-driven engine that runs hundreds of packets per second kind of speed. And someone can contradict me if they think it runs a lot faster than that, but generally speaking, this is like an educational simulation tool, whereas this is commercial grade data plane. But they're both pure
right.
software.
No, that's good. Thank you,
Yeah.
Chris.
Yeah.
I initially thought that perhaps you're only doing the traffic testing only with the DPDK and not with the BMV2, but it's good that we have it covered on both areas. And
Oh, yeah.
I presume you will be doing PTF for the BMV2, correct?
PTF, yeah, PTF and beyond. There's another approach too, where I'll talk about where we use much more performant traffic generator that has an open API. And actually, there's so many sort of deep dives on this. I don't want to spend too much time on some of the details so I can cover the broad strokes. But I did do a talk with Reshma from Intel about this whole approach. And we talked about Dash and about Dash testing. And there's a video link at the end of this slide deck, which I will share, that you can watch that P4 workshop talk that explains this in more detail. So, Rex, you had a question?
Hey, Chris, this is Suresh. A question for you. I mean, my question is pretty fundamental, right? So the whole purpose of having a P4 based definition for Dash behavior was, to have a, well understood behavior specified. Now, I understand that, using BMV2 for the testing, of what we defined in the P4 makes sense. But why should we expand this to P4 DPDK and all other methods? I understand from a P4 perspective, yes, that is probably a piece. From a Dash perspective, does it make sense to add all these different paths for this? I mean, performance targets, DPDK performance is not going to match with the performance requirements of smart switch or other appliances as Microsoft needs anyway. So the intention should be for testing the behavior, not really performance, for which BMV2 should be good enough, right? I'm just trying to understand the rationale.
Yeah, the P4, Chris, if I can quickly add
Yeah,
one.
thank you, Reshma. I'm glad
Sure,
you
sure.
can step in.
Thanks. For P4 DPDK, it's a DPDK with P4 programmable DPDK, right? So we have the P4 program for the DPDK backend that has the features that we need for underlay as well as connection tracking and overlay as well already, and what we are doing is to have a Sonic running in a VM. So Sonic soft switch, right, with P4D PDK, then you have basically all the Sonic software stack that is same that can be used for soft switch as well as hardware. So once we have the Dash container and all the code required for Dash, and that's there in Sonic, right? We can use the same stack for both, for development environment, as well as if there are some NICs that will run DPDK, for example, which are not smart NICs or IPU with high powers, high capacities of memories and all that, right? So this has a lot of advantages. Mainly here in the community is that it will be just PNA compliant, and it will have connection tracking and overlay features, and the Sonic software stack can be used, for both soft switch and hardware. In this, it's the same stack can be used.
Yeah, and just to be clear, this is not, in the next few weeks. This is kind of, and Reshma can comment more on the timing of this, but this will follow this initial work. And by the time this is available for this kind of test, we'll have invested a lot of time in the common framework to make all of this work. So it should not be like twice the amount of work to test both models. Most of the work will be put into developing the framework and common infrastructure here. And this provides yet another cross-check of the entire design and PNA implementation. This will probably be an ongoing discussion, but it's a good question, Suresh. Thanks.
Yeah, Reshma, I have no argument against, on the DPDK advantages over a software simulator, right? But my concern is that when we start an effort like this, over a period of time, it will diverge and create confusion on, what is the real target to be testing with. So, and that's what I've seen in the past too, and that's the reason I'm bringing it up.
Sure. I think as in Chris's, test scenarios that he has listed in the Dash repo, basically there are several options and several levels of how we can test, below Sonic using SciPTF, right, and using Sonic with when we talk about using Sonic, how we test in the soft switch, I think this will be, advantageous because we are using the Sonic in VM. We can instantiate multiple VMs and use the P4DPDK pipeline and write our own P4 programs, and we can give the P4 programs that we have, which we will open source as well, which will cover underlay and the connection tracking, etc. Right? So yeah, it will be a full stack, even in the development environment, to be used anywhere in some of the NICs that you may have that are not as powerful as the IPU DPU. Yeah, those are the advantages I see.
Yeah, so I mean, what we should do as a community is, if we think one over the other is more advantageous and better, maybe we should stick to that. And I don't know if the time has passed beyond, I don't think we are at that limit yet, or we've decided on something, so we cannot switch. Maybe we still have room to decide. I don't know. I'm not sure what others are thinking.
Yeah, there were similar such thoughts earlier as well.
Yeah, I think it's a real good point. And why don't we just keep that as kind of a discussion item, that's probably going to be ongoing, and, take those comments and then move along on this presentation. And we can, that can be an open thing, because there's nothing being done right now that's going to derail one choice or the other. I think right now they're kind of like, two future possibilities here. So let's just keep that in mind, and then as we go forward. Thanks, though. So, yeah, skip the animation. So I just want to talk about the P4 model testing, regardless of which model, but for now, I'll just say it's BMV2 for the current discussion. And these are kind of the goals. We want a framework which can do regression testing in the cloud, as part of GitHub. When something happens like a commit or a pull request, it will trigger this set of actions. And here's what gets done when you trigger the actions. Right now, all this stuff in green can be done manually with Marian's latest merge, which was very timely. And I just actually reconfirmed all this morning and last night that this all works by just doing these manual steps. But it builds the serious pipeline P4 code. It creates the side headers from the P4 info. It creates the BMV2 switch and P4 runtime server, which is a process you can run. It creates a side library to P4 runtime client adapter. And then there's a trivial test that does a table accessor. Doesn't send any traffic yet. And so the step that, oh, go ahead.
I just said, wow.
Yeah. This is what's working today. This was actually working many weeks ago. I've tried this out and been kind of a guinea pig along the way, and it's pretty cool. And this is what the repo looks like, as of last night. You just do these steps, it all works. And some of the steps we need to do to complete this automation test is we need to integrate the SciThrift server, because right now this is just a Sci library binding. We need to configure the device under test through SciThrift, spin up a traffic generator, a software one, actually pass traffic between the ports, the virtual Ethernet port to the data plane. And then longer term, we want to test successfully the higher layers in the stack so that we're ready for pure true sonic integration. And then finally, use these same test cases with hardware tests, using hardware traffic generators and actual, smart NIC cards. So that's kind of a broad overview. And this is just for reference. I've talked about this diagram a number of times, and I also talk about it in that video I mentioned. This is kind of the overall workflow where the P4 code, that's part of the behavioral model working group, is used not only to make a software target, a BMV2 target, but also generates all these artifacts which can be used to do testing. It generates Sci headers. It generates it can be used to generate a SciThrift server, which you can actually use to test the target with. And then test scripts would configure the device using SciThrift, configure a traffic generator, send packets to the device and test. And this can all be triggered manually or by a GitHub action. So this is kind of the broad strokes. Another diagram I want to, I have all this animation I didn't take out. Just forget about that for now. One other thing I wanted to mention is I would like that we can have test cases that can test the different layers of the Dash Sonic stack, starting from the bottom up, where first we're testing with SciThrift, Sci API of the implementation, and this will be a software implementation. And later, as you work your way up the Sonic stack, you want to test the Sci Redis interface, which doesn't use all of Sonic. It just uses really the Redis and syncd parts of Sonic. And then finally, testing through the GNMI northbound interface, which is the SDN interface. In principle, you could write a test that could be used to drive all three of these interfaces. And that remains to be seen how well that will work, but we're going to proceed as if that is possible, and by using the appropriate drivers and wrappers. So you could write a test case, for example, to set up a VNet and all the encapsulation and mappings and test it at the Sci level, the Sci Redis level, and the GNMI level without redoing all the work from scratch each time. So that's another overarching goal. So we have common test cases will drive multiple interfaces, starting at SciThrift, Sci Redis, and then GNMI. So here's what happens when you trigger a Git action, and we're just beginning to prototype this. A test runner gets allocated in the Azure cloud, and this is free for public projects. And you can read about that in one of the links at the end of this slide deck, but GitHub explains how to do that. It will build or retrieve a pre-built Docker image containing the toolchain. This is the make Docker target that Marian created. So it builds all these tools into a Docker so that you basically have a complete development environment to build all the rest of the things. So it's going to pull all these tools in, build them, pull them from, Ubuntu package repository, build all these tools. And then you have a Docker image, which is basically then a nice little self-contained build environment for everything else. So using this Docker, it compiles the P4 model, produces all the artifacts, eventually the SideThrift server, which is not done yet. It will launch the switch and the SideThrift server. Then we'll launch some traffic generators, which we'll talk about. We have this free DPDK traffic generator that's much better than Scapy, and it can actually go up to quite performant levels. Then it runs PyTest to configure the data plane, send traffic, and analyze the results. Produce some kind of report, probably do an automatic status badge in the GitHub repo so you can see like pass, fail, and then shut down. And that can happen just by doing a pull request. So that's the grand vision. I'll stop for questions.
So, Chris, just a quick question. So this basically will start as soon as the pull request is submitted?
Yes, or if you do a commit even. Yes, pull request or even a commit in your local branch if you want it to.
Okay. Yeah, so this will become like one of the gates for something to be accepted as for approval purposes, right?
Correct. And a lot of companies use this process internally, but our development teams at Keysight, this is like baked right into our process. You do a commit and it kicks off the pipeline. You can see immediately if all your regressions passed or failed, and Deanna here can attest to the value of that.
Yeah, so this is basically enabling continuous integration, like reliable changes and all of that. Right?
Yeah, and over time, as you add test cases, you might have hundreds of regression tests, and you do a commit, you immediately get confidence that you didn't break everything.
This is great. This is awesome. I think we definitely need this thing because as we start to accept more PRs with all the new behavior model work is going on, this will be extremely required for us. Right? So
Yeah, thank you. So let's just talk a little bit about progress to date. We literally just started this yesterday, and we've got some good progress, but we also flagged some issues which we need to work on. So there's a couple things. One is the automation part, which we started last night. Actually, the overall project of the framework, getting resources, schedule, and dependencies. Keysight wants to make a lot of contributions in this regard. So we're still studying the overall plan for all these test cases, et cetera, and the larger test framework. But right now, Deanna's working on the automation part and testing the GitHub Action, just the basics. And the first thing we want to do is just reproduce all the manual steps that Marian documented in his README of making the Docker, kicking off the switch, and making one table access over the SI interface. And so here's a picture of like the console that happens when you kick off a job. And what it does, it set, I guess, Deanna, you did like a commit to your repo and it kicked off it.
We can even show it, Chris, if you want to, in the
okay.
The web page.
Sure, we'll do that in a minute. That'd be great. So it kicks off a job, and this is the first step, make Docker, right? And it's pretty slow. This is an hour and 5 minutes, and it's barely got started because it's kicking off a 2-core instance of an Azure runner, of a GitHub runner in the Azure cloud. You don't get the biggest, fastest CPU all to yourself. You get whatever they give you because it's free. So it takes a while to run, and you can see after 2 hours, it finished building the Docker. Now, if you do it locally on a fast tower, it's much faster than that. But this is a cloud build, and I'll talk about what we're going to do about trying to speed this up, because you don't want to do a commit and wait hours to see if it passed, right? You want to know pretty quickly. And then we're just starting this, so yes.
Do we need to build Docker again and again? Because once you have built one Docker image, then you can reuse this thing, right?
It's like I paid you to set me up for the next part of this talk. Good job. Yeah, now we've got smart people on this talk. You can give about half the talk and then just end the meeting because everyone can figure out the rest. Um, so we did another run where this just built the Docker, and then we added more steps where we tried to build like the software switch, and we ran into some error, and I think it's probably a resource or is a console IO issue. Is that right, Deanna?
Yes, I just need to customize a little bit the Docker file to remove the interactive.
Yeah, like you probably can't read this, but here it says Docker run -IT. That means an interactive terminal. Since it's running in the cloud, you have to turn that off. So, we're just starting to adapt this manual process into an automated one, and you just have to kind of peel the onion layers. So let me go to the next page. Oh, Deanna, did you want to take over the screen for a second and just show it live?
Well, yeah, I only have 1 more minute, but yes, let me get
Oh,
this.
right, you have to go to another meeting. If it's not good timing, we can.
Yes, let me show you. Let me show it next time.
Okay. Yeah.
But let's make sure to cover the issue with the Docker image, having to build it every time as opposed to
Yeah, let's see if I have I don't have.
That's the most important
Yeah.
thing
So
that we need to proceed.
so as Hannah correctly said, we should only have to build this Docker once because it's just a fixed set of tools, and it may change from time to time, but very seldom once we get this stable. And if the Docker were already built and all you did was have to retrieve it, this whole thing would run in minutes, just really quickly. So what we need to do is figure out a workflow where we can build this Docker and store it in some kind of a Docker repository, whether it's Docker Hub or somewhere in the Microsoft Azure cloud. And so that's a dependency that we want to discuss in this meeting, but we may as well talk about it now. We need help or suggestions in having a resource where we can store a pre-built Docker and retrieve it on the fly. And is anyone in this meeting familiar with how that might be used already in Sonic? Is that a common workflow? That there's some kind of a Azure Sonic or Docker hub that we can use? Okay, so that's one of the dependencies that we need to explore. And we'll ask around, and we might need some help from the Microsoft side to identify a resource. And we might set up some temporary Docker hub just so we can do development on this, but we'll need some kind of a place to store pre-built artifacts, because this whole CI/CD pipeline should run in a couple minutes.
It looks like Prince is on the call. He might know. Unless he's on
Hey,
two
Krishna.
calls. Hey.
Okay, I think I heard about the build management, right? To facilitate the Docker part.
Well, what we need is a Docker hub of some sort, a repo to store pre-built images.
Oh, okay. So okay, at least for Sonic, we have some Azure pipelines and Sonic storage. So I'm not much familiar with how the build team is handling that. But if you need, we can have like some offline discussion with the build team and understand how and what they are doing. Yeah,
That would be really helpful. I guess what I would do is simplify to, if there's some kind of a account we can use even provisionally just to store an image and do some experiments, that would be really handy. Even if we change it later to some more official repo, just
okay, yeah,
kind of get through the critical path, because each time we do a test, it's 2-hour wait, just to see if we may fix the shell script problem, and we need some way to speed this up.
Sure. I think I got it. So maybe Krishna, we can get the requirement and we can have an internal discussion with the build team to on how to facilitate that.
Right, that would be appreciated. Super.
Should I ask further if it's a possibility to get like a donation into this project so we don't use a free VM and use a more powerful one to speed it further? Instead of using the free one with 2 cores, I don't know, can Dash project get like a grant or something so we can buy a 16-core VM or something?
I guess that would be another part of that discussion that Prince mentioned. Maybe it's just what's the best way to expedite speeding this up without getting, without trying to boil the ocean, so to speak. Just some faster private runner, right? That would be a private GitHub runner. So there's kind of two types of runners. There's sort of free ones that are floating, that get assigned on the fly, that are pretty low performance, like 14 gig of memory, 14 gig of disk space, and 7 gig of RAM, and 2 cores. And then you can have, dedicated runners, which are speedy. So want to ask those questions too. Thanks, Merchant. So let me go to the next slide. Let's see, where am I? So what are some of the dependencies going forward to make continued progress? We need to get the SciThrift server linked into what Marian has already put together for us. And I'll go back and refer to this. Let's see, all these silly animations I should have turned off. We don't have this part grafted onto libsci. Right now, what we have is libsci, and then if you replace this box with a simple C++ program that does a couple of table accessors, that's what's working right now. What we need is this SciThrift server, so we can have a general RPC mechanism to run test scripts on. So that's an effort where we take and there's 2 parts to that. Let me go back to my list. Certainly, Intel's working on enhancements to SciThrift, and Reshma's spoken about that before, where they're modifying the existing SciThrift framework to be able to handle, smart devices with 2 ports, not full sonic switches. And eventually that needs to get merged into OCP Sci. Although we could use a development branch right now. We're kind of experimenting here, so we could just use the dev branch that's underway if it's close enough. But then we need to integrate that into the Docker build inside Dash so that we have a full server. So we need help to do that, and preferably someone who already has a lot of experience in this SciThrift server area. They'll need to do some kind of a GitHub submodule or something, pull it into the Dash project, link it all in. We're going to need to choose some exemplary test cases and agree, what would we like to test first, just as a kind of a hello world of this whole framework. That's something we can, agree on. Someone could propose, like, let's do a simple underlay and a simple overlay test. We need the P4 model working to be able to pass some tests. Even you could just test it on the command line with, Scapy or something, just to configure the P4 model with some kind of a service config, send the packet into it, make sure the output is right. Then we can work on automating that. But we need some kind of a model, and we need to pick milestones and checkpoints. Like, okay, the model's ready to do X, so let's try out X and agree that that's a tagged or a committed version that we can start testing. And we need semi-stable Sci interfaces to Dash, and that could come from the P4 code itself. This is kind of a big one, and I've been talking about this for several months, but it's getting time to where we'll need this. We need some kind of a configuration schema that can describe the configuration of the Dash data plane, so that we can say, well, here's a config. What we don't want is to make everything purely procedural, where you have to write a program every time with a bunch of Sci access commands. We want, for example, a JSON file that says, here's the config. And there's some provisional ones in the repo right now that Prince has put up several weeks ago. It's kind of an example of the kind of configuration, but we really need to settle on something that's semi-stable, so we can use that as our common test format. And I've been talking with Prince on the side about this, and we'll probably have some little working sessions to talk about that. Ideally, we have a test that says, okay, here's your VNet configuration and your mappings and your routes to JSON file, or a program that can generate a JSON file. And we can use that to run tests at all the different layers in the stack long term. And ideally, there's a way to just import or export that from Redis so that this configuration can be reproduced easily. And then we need this Docker image repo of some sort, which we talked about. And Murcha actually alluded to this, more powerful GitHub runners. So this can run even faster. So these are some of the dependencies, and I'd say the first thing we need is to talk about how to get this done. You know, we can talk about it here, or we can talk about it offline or in another meeting, but this is going to be coming up pretty soon. So
Well, we have a few minutes. We could talk about some of it here.
Yeah, and let me just see what the next slide is, just to see if there's any. Oh, let's talk about next steps, and then we can back up on these things. I think the needs are here. So the next steps, getting this current CI runner, and Deanna's working on this, you know, in real time. It will probably, I feel pretty confident that this will get proven out pretty soon. The SideThrift enhancements for Dash with Intel has already been doing for some time. We need to get SideThrift server, so we need someone to volunteer for that. And then the overarching test harness framework, we're working on actively defining this. And we would like to be able to contribute this to some test cases, which can be an ongoing discussion. The P4 working group needs to decide on some level of functionality and say, this is what we're shooting for, and we can confirm it works. And, you know, we need to be able to send the packet into the data plane and get it back out and say, yes, this does what we expect. And then what we want to do is automate that into the framework. Define a JSON configuration schema. Get the Docker repo, and I should say also maybe faster runners. And then we should decide at some point, when are we ready to have a regular test working group meeting cadence? Because this can probably be, you know, its own focus. So I know we have a lot of meetings going on already, but people can kind of just focus on this one topic and not necessarily make it part of the weekly meeting, this weekly meeting, but that's a choice. So that's just kind of a snapshot in time of my thoughts on this, and I welcome discussion and feedback. This is just a proposal.
No, this is great work. Yeah, thank you so much, Chris and Keysight team. I really appreciate it. I think this will go a long way in really ensuring that we have a quality work that is coming in, because once we have this gate, we can really determine that whatever is getting accepted is thoroughly vetted out. You know, so it is excellent. So one question, you know, this workflow really talks about, you know, running the regression to ensure that, okay, we're protecting whatever is already existing, right? So now the question here is that if somebody is really putting in something new, then that something new should come with its own set of test cases, right? How do we ensure that, you know, we actually make that one as part of the complete, you know, the test inventory that we have of the test suites? So I'm sure there will be different workflow to really submit the test cases, correct?
Yeah, that's a great question, and it gets into this area of kind of policies and conventions for this project, right? As we get a little more serious, no pun intended with serious pipeline. So I kind of came up with this thought. I was sharing with a colleague. I said, you know, going forward, if someone adds a feature or makes a change, they're responsible for the tests. If they break a test or the test has to be changed because we changed the behavior, then that party's responsible for both. They can't break the repo, so to speak. That's kind of the convention a lot of companies follow internally. You know, if you make a feature, you're expected to contribute tests for it, even if it's just a starter test, but kind of a unit test or a functional test. And if you break existing tests, it's up to you to reconcile everything. That's kind of a overarching policy, and we have to decide as a group, is that how we want to proceed?
Well, I have two thoughts on that. You know, we used to, at Microsoft, we used to have an entire testing group, STE, software test engineer, and then we had SDE for development engineer. And as we moved along through the years, because testers are always intent on testing and breaking things, and developers sometimes have blind spots as to how to test, you know. But at Microsoft, we moved into wrapping the testing into the developers' work. You know, as if you develop, you should test as well. I don't know how well that works because it's just a different mindset. That's just my opinion.
I'd like to comment on that. First of all, the projects I've been working on in Keysight more recently, like with Deanna and others, we exactly do that. We don't have a test group. We are the testers, and we write tests with our, when we do a feature, we write the unit test for it, the functional test at the same time. And the developers sleep a lot better because they don't have it coming boomeranging back to them later.
Yeah.
It's just done. And it feels, sometimes it feels like a chore. But when you really step back in the big picture, it's actually easier. And other companies have adopted this. I mean, this is really continuous integration in a nutshell. And it's kind of the modern mindset. And throwing it over to an SQA group is sort of a thing of the past. And, you know, it's kind of a well-known maxim that the longer, the deeper into, or let's say the later in the production schedule that a bug is found, the more expensive it is, and goes up exponentially, right? If you find it when you type commit 5 minutes later, that's like cost you 5 minutes to backtrack and fix it. If you find an SQA, you got to file a bug report and have meetings and bug scrubs and blah, blah, blah. If you find it in production, ouch. If you find it in the field, mega ouch, right?
I remember, you know, 20 years ago when we had all the testers, some of the interview questions are like, how do you test a Coke machine? And then you just leave it. And they would have to come up with, you know, they have no idea what you're talking about, or, you know, they happen to be able to come up with something. So I agree. I think earlier in the process is good.
I have a comment here. From experience with like Python projects and other projects, there are like coverage tools which will give a percentage coverage, and then you can make automate in the pipeline and say, if you don't meet the coverage, just reject it. So that could be automated. But in this case, I do not know how that could be realized, because I don't know if there are tools that can provide coverage for the tests that we will add in order to be able to automate that portion and make it not a policy, but actually make it enforceable automatically. So that will be something that maybe we can research and see if anybody has any idea how we can automate that process.
Yeah, well, since we're testing the data plane to begin with, and then the APIs on top, I think we need some P4 test coverage experts on that conversation.
Yeah.
But it's a good point. And, you know, this is going to be incremental, right? We're not going to suddenly dump a giant process on everyone and make their life a drag. We want to do this in an organic way so that everyone's seeing the benefits along the way and not feeling like it's a chore. But, you know, we want to stop bugs early. That's the bottom line. Companies like Arista, when my ex-boss went there some years ago, he said they don't really have hardly any QA department. They make sure like power supplies are working and cards plug in. The developers write all their own tests, and no one can argue that they aren't doing pretty well. So the newer companies pretty much do that, I think, almost from day one. So anyway, you know, thanks for letting me present this, and you know, I'm hoping we can give a nice update at the next meeting, see how things are going. So people don't need to see my installer.
Thanks, Chris.
So, Chris, are these slides already on the GitHub?
I will share them.
Thank you.
I'll upload them into the slides deck, and then Christina can get the link.
You give me a link for it, and I'll publish it.
Yeah.
Sounds good. Thank you.
And I was also hoping it would be okay, like I did with Marian's demo, to do little tiny snips that I put into the weekly notes, just so people don't have to click anything if they want to just see it in the email. Is that okay?
Oh yeah,
I won't put everything in, but yeah, no, a link would be great too. Thank you.
Yeah.
Any other agenda items today, guys, from the rest of the crowd? Please. I know we have quite a few things to follow up on, but you know, please email me if there's something particular you want to discuss, or maybe something I can track down internally. Like I said, the dev team is pretty focused on getting their proof of concept out the door, but I'm happy to try and help. I'll stop the recording now. And everyone knows my address, krisney@microsoft.com. Okay, well, thank you, everyone. I guess we can give 12 minutes back today.
Thanks, you all.
Okay, I appreciate your time.
Okay.
Yeah.
Bye-bye.
Thanks. Bye.
Thank you, Marian.
Bye.